morning all. This is Dr. D. Khalandar Basha working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the description of 8086 microprocessor course. The course overview. The processor and controller cores are the key component in most of the modern embedded and system-on-chip designs. This course outlines the architecture and the signal description of Intel microprocessors and microcontrollers. Exclusively, we are going to study the 8086 microprocessor and 8051 microcontroller. The instruction set and assembly language programming along with I/O and memory interfacing techniques are covered. The knowledge acquired from this course will enable the students in the development of embedded hardware projects and models for engineering and scientific applications. The course objectives. The objective of microprocessor system is to make the students will try to learn the signal descriptions along with the functional architecture and hardware interface skills using microprocessors and microcontrollers, the instruction set and logic to build assembly language programs for arithmetic, logic and automated electronic systems. The essential concepts of development through a practical hand-on approach on advanced microprocessor and Internet Things based system. The course outcomes. After successful completion of the course, the student should be able to get the following outcomes. The first course outcome is describe the features of Intel processors and microcontrollers for signal description and architecture. The Bloom taxonomy level is understand. The course outcome 2 is make use of addressing mode and instruction set of target microprocessors and microcontrollers for writing efficient assembly language programs. Here, the Bloom taxonomy is apply level. The course outcome 3 is demonstrate the internal architecture and modes of operation of various peripheral devices for interfacing memory and I/O devices. This course outcome, the Bloom taxonomy level is understand level. The course outcome 4, it is for illustration the interrupt handling mechanism in microprocessor and microcontroller using the interrupt controller system. The Bloom taxonomy level is understand. The course outcome 5 is choose an appropriate data transfer scheme and hardware for data transfer between the devices with the Bloom taxonomy level apply. The course outcome 6, it is for develop microprocessor and microcontroller based applications using appropriate input and output devices. So here the Bloom taxonomy level is applied. The mapping of COs and POs. The CO1 is mapped to PO1 and PO10. CO2 is mapped to PO1, PO2, PO3 and program outcome 10. CO3 is mapped to PO1, PO2, PO3 and PO10. CO4 is mapped to PO2 and PO3 and PO10. CO5 is mapped to PO2 and PO3 and PO10. CO6, course outcome 6 is mapped to program outcome 1, 2, 3 and 10. The program specific outcomes. We have 3 PSOs. The 8086 microprocessor system is mapped with the PSO with the course outcomes as shown in the table. CO2 is mapped to PSO1. CO6 is mapped to PSO1. The syllabus of 8086 microprocessor courses. In the module 1, we are going to discuss the 8086 microprocessor. The various topics which we are going to cover are 8086 processor architecture, the various blocks inside of the architecture and its functionality, Register organization, this will describe the various registers existing in 8086 like general purpose registers, special purpose registers like segment registers, pointers and index registers. Memory segmentation. So in 8086 processor, how the memory is segmented into various blocks. So how to access the data from the memory for read and write operation, how to generate the physical address, we are going to discuss under memory segmentation. The signal description of 8086. Under this topic, we are going to study the various signals, that is pins present on 8086 microprocessor. It will signify the functionality of each and every pin of 8086 processor. Then modes of operation with the timing diagrams. As the 8086 processor, we can operate in two modes, that is minimum mode and maximum mode. That operation we will see with respect to block diagram and timing diagrams for read cycle and write cycle. The interrupts, how the 8086 processor will handle the interrupts, what are the various classification of the interrupts, that we will discuss under interrupts concept. Addressing modes. The addressing modes will describe the method how to pass an operand in an instruction. So what are the various modes of addressing modes we are having for 8086 instruction set, that we will see under addressing mode. The instruction set of 8086 processor, which will involve what are the various instructions will be supported in 8086 like data transfer instructions, arithmetic instructions, logical instructions, string manipulation instructions, control transfer instructions, next string manipulation instruction, processor control instructions, flag manipulation instructions we are going to study under instruction set. The next topic is about sample programs involving the arithmetic, logical and branch call instructions, sorting, string manipulation instructions. Module 2, it is corresponding to the interfacing of 8086 with the memory and IO devices. So how the IO devices we can connect to the 8086 processor. Similarly, how to interface or to connect a microprocessor with the external memory. So in this module, we are going to discuss PIO, that is Programmable Input Output Device 8255, the various modes of operation, and few applications like interfacing stepper motor and DAC, ADC, digital to analog converters, analog to digital converters with 8086 processor. Then we are going to study the memory interfacing, the semiconductor memory interfacing for both dynamic RAM interfacing. The last one we are going to study is the data transfer from processor to the processor and from the processor using USART, which is 8251, Universal Synchronous Asynchronous Receiver Transmitter. This will support both synchronous communication as well as asynchronous communication. In the module 3, we are going to discuss the 8051 microcontroller, which is a product of Intel. Under 8051 microcontroller, we are going to study the internal architecture, which is consist of various components, various blocks of 8051 microcontroller we will study, and its significance. Then pin configuration, the various signals or pins corresponding to 8051 microcontrollers we are going to study under this topic. 8051 addressing mode, the various addressing modes supported in the instruction set of 8051 microcontroller will be studied under this topic. Instruction set, the various instruction set like data transfer, arithmetic, logical and control transfer instructions we are going to study under instruction set. The bit addressable feature, so when you are accessing the memory, usually we are going to send bulk bits like 8 bits we are going to send for each data transaction, whereas in 8051 microcontroller we have a facility of accessing a particular bit also. Few memory locations are there with a bit addressable capability, as well as few registers are there for configuring either for set or reset particular bit of few SFRs that we will see under bit addressable features. IO ports, in 8051 we are having 4 ports, namely port 0, port 1, port 2, port 3. What is its configuration, the internal architecture of it, how to configure a port into input mode or output mode, that we are going to study under IO port structures. Then assembly language programming using data transfer, arithmetic, logic and branch instructions. In the module 4, we have the system design using a microcontroller. In this module, we are going to see the various peripherals are available on 8051 microcontroller on chip, like 8051 timers and controls, serial data communication, and its programming. 8051 interrupts, interrupt programming. So on 8051 microcontroller on the chip, we have few SFRs like timing or counters, serial port or serial communication. The last one is interrupt handling. In 8051, we are having two timers, that is timer 0 and timer 1. These timers we can configure as timers or counters. These timers we can use in 4 modes: the 13-bit timer, 16-bit timer, auto reload mode, split mode. This we are going to study under 8051 timers and counters. The corresponding SFRs like T0 register, T1 register, T mode register, TCON registers. How to configure it, what is the functionality of each and every bit, we are going to study under these topics. Serial data communication, it is for transmitting the data or receiving the data. In 8051 supports UART, that is asynchronous receiver transmitter. So how the data will be transmitted or received, we can see in the serial data communication. The various SFRs corresponding to serial data communications are SCON and PCON. Here also the data will be transmitted 8-bit size and 9-bit size. So how to configure these SCON and PCON registers, we are going to study in detail. In the interrupt mechanism, in 8051 microcontrollers, we are having mainly the interrupts are external interrupt 0, external interrupt 1, that is INT 0, INT 1, timer 0, timer 1 interrupts. Apart from that, serial communication interrupt for transmit interrupt or receiving interrupt. These 5 interrupts, how to enable, how to give prioritization. So how to handle these interrupts, we are going to study under 8051 interrupts and interrupt programming. Next, we are going to study the real world interfacing of 8051 with the memory, expansion of IO ports, as 8051 microcontrollers consist of only 4 ports. So if I want more than 8 ports, how to expand the IO ports, we are going to study under expansion of IO ports. Next, few IO devices interfacing like stepper motor, analog to digital converters, digital to analog converters, liquid crystal display, that is LCD, with 8051 microcontroller. We will see interfacing and its programming. In the module 5, we are going to study the ARM architecture. Under this module, we are going to study the ARM processor fundamentals, ARM architectures, the various registers supported in various modes of operation of ARM processor, CPSR and SPSR, current program, status register, pipeline. So how ARM processor will support pipeline, what are the various stages we are having, that we will see under pipeline architecture. Exceptions and interrupts, interrupt vector table, what are the various exceptions we are having, interrupts we are having, how to handle these interrupts, we are going to study under interrupts concept. ARM instruction set, the various instruction set supported by ARM processor like data processing, branch instruction, load store instruction, software interrupt instruction, program status register instruction, loading constant. This we are going to study under instruction set. Then conditional execution, and we will see the thumb instruction set, how it is different from normal ARM instruction and thumb instructions, how to configure the ARM processor to the thumb instructions, what are the format or syntax differences there for ARM processor and thumb instructions, we will see under introduction to thumb instructions. References, the various textbooks we can prefer for learning the microprocessor microcontroller course: A.K. Ray and K.M. Burchendi for advanced microprocessor and peripherals by Tata McGraw-Hill publication. Next, Kenneth J. Ayala, the 8051 microcontroller, Senge's Learning, 3rd edition. Andrew and Sims write ARM System Development Guides, Elsewhere publication. So the first book is preferable for 8086 processor. The second textbook, the 8051 microcontroller, is useful for learning 8051 architecture to programming and system design. And the last one is it is for ARM processor. So the first textbooks we can use for first 2 units, chapter module 1 and module 2. The second textbook it is used for learning the module 3 and module 4, and module 5 we can learn from the textbook 3. Apart from the textbooks, the various reference books we are having is N. Senthil Kumar and Saravanan, Microprocessor and Interfacing, Oxford University. Laila B. Das, the x86 microprocessor, Pearson publication. Douglas V. Hall, Microprocessor and Interfacing, which is Tata McGraw-Hill publication. Thank you all. So in this, we have described what is the course objective and course objectives, course outcomes of 8086 processor. Then these course outcomes, how to map, what are the various POs, program outcomes will be configured with CO, that articulation matrix we have studied. Then PSOs and CO relation we have studied. Then we have gone through the entire curriculum or syllabus of the 808 microprocessor and microcontroller subject. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.